Hello, and welcome to Sleepy Starlight Channel. I'm so glad you're here tonight. Maybe your day was long, or maybe you're simply looking for a calm voice to help you unwind and drift into sleep. Tonight, we'll take a gentle journey where science becomes a story and curiosity leads us softly into dreams. Let us begin our journey with something that touches every life on Earth, the weather. It surrounds us, moves through us, and shapes our world in ways both gentle and grand. Every cloud, every gust of wind, every flash of lightning tells a story written in air and sunlight. The weather is not chaos. It is the breathing of a living planet. When we look up at the sky, it seems so simple, blue, endless, calm. But what we see is only the surface of a vast and ever-changing ocean made of gas. The atmosphere is Earth's invisible sea, an ocean of nitrogen, oxygen, and water vapor flowing above our heads. Every second, air rises and falls in great tides, carrying heat, moisture, and momentum around the world. The story of weather begins with the sun. Its light falls unevenly across the planet, stronger at the equator, weaker near the poles. That uneven warmth sets the air in motion. Hot air expands, becoming lighter, and rises. Cold air sinks to take its place. This simple difference, warm rising, cool sinking, is the heartbeat of the atmosphere. It drives wind, storms, and seasons, linking all corners of the globe in a single delicate system. As warm air rises, it cools, and water vapor within it begins to condense. Tiny droplets form around microscopic particles, bits of dust, salt, or pollen, and a cloud is born. Each cloud is a floating collection of countless droplets or ice crystals, drifting where the winds carry them. Some clouds are thin and feathery, like brush strokes across the sky. Others tower like mountains, their tops shining in sunlight while their bases fade into shadow. Clouds are not only beautiful, they are storytellers. They reveal what the air is doing above us, whether it is rising or falling, dry or moist, calm or unstable. A cirrus cloud, high and wispy, often means fair weather. A cumulus, puffed like cotton, shows warmth rising from the ground. A towering cumulonimbus, with its anvil top and dark belly, is the mark of a thunderstorm, the sky's own symphony of power. Inside a thunderstorm, air moves faster than any bird could fly. Warm, moist air surges upward, cooling and condensing as it climbs. Each droplet releases heat, feeding the storm's strength, pushing it higher still. At the top, near the edge of the stratosphere, winds spread outward, flattening the cloud into a vast, glowing dome. Within that turbulent world, raindrops collide and grow, hail forms, an electric charge builds silently until, in an instant, the balance breaks. Lightning is one of nature's most astonishing phenomena. It begins invisibly as a separation of charge inside the cloud. The upper parts become positively charged, the lower parts negative. The earth below, sensing this imbalance, becomes positively charged in response. When the difference grows too great, electricity leaps across the gap, a spark miles long, hotter than the surface of the sun. It illuminates the sky for less than a second, but in that blink, it releases tremendous energy. Thunder follows, rolling across the landscape. It is the sound of air expanding and contracting violently as the lightning bolt heats it. The flash reaches us first because light travels faster than sound. The rumble arrives later, telling us how far away the strike occurred, roughly 3 seconds per kilometer. To ancient people, lightning was the voice of gods. To science, it is still something almost mystical. Order emerging from chaos, a reminder that the atmosphere is alive. rain itself is another miracle. Each drop begins as a speck of dust wrapped in moisture carried aloft by wind. When enough droplets gather, gravity pulls them down. They fall through layers of air, growing and merging as they descend. By the time a raindrop reaches your hand, it may have lived 1,000 small lives, rising, falling, freezing, melting, before finally completing its journey from cloud to earth. Every raindrop is part of a greater cycle, the endless circulation of water between ocean, sky, and land. The sun evaporates water from the seas. Winds carry it across continents. It falls as rain or snow, feeds rivers and lakes, then flows back to the ocean. The same molecules of water have traveled this cycle for billions of years. The water you drink, the rain that falls on your roof, may once have flowed through ancient rivers or drifted in the clouds above lost continents. Snow and ice are simply different forms of the same dance. When air is cold enough, water vapor turns directly into crystals. Each snowflake grows around a tiny nucleus, building delicate arms that branch in symmetry. No two are exactly alike, yet all obey the same hidden geometry, hexagons shaped by the laws of physics. When millions of these crystals fall together, they soften the world, turning noise into silence, motion into calm. Wind, too, is part of the Earth's long breath. It begins with differences in temperature and pressure, but it never moves in straight lines. The planet's rotation curves every current, creating great spirals, the trade winds, the jet streams, the cyclones and anticyclones that weave weather patterns around the globe. A gentle breeze at your window is connected in a small way to vast currents circling the planet. Storms are not enemies. They are expressions of balance. They move heat from the equator toward the poles, helping Earth shed excess energy. Without them, the tropics would grow unbearably hot and the poles impossibly cold. Even hurricanes, those great spiraling giants of the ocean, serve a purpose. They draw energy from warm seas, redistribute it, and fade when that energy is spent. Destruction in nature is rarely meaningless. Weather is also music, invisible but rhythmic. The whisper of rain, the hum of wind through trees, the distant roll of thunder, all are part of Earth's constant song. The planet is never truly still. Even on the calmest days, air moves, water evaporates, and clouds drift. To listen to weather is to listen to the heartbeat of the world, and sometimes the weather transcends the ordinary. There are phenomena so rare and delicate they seem like dreams, halos and sundogs, where ice crystals bend sunlight into rings and phantom suns, rainbows forming in mist, their colors born from reflection and refraction. The green flash that flickers at sunset for a moment so brief you doubt it was real. Each is a whisper from the sky, a fleeting glimpse of the infinite playing through light and air. Beyond weather lies the greater theater of natural phenomena, earthquakes, volcanoes, auroras, and tides. They remind us that Earth is not a passive stage, but a living system. The same heat that drives the atmosphere also stirs the mantle beneath our feet. The same solar wind that brushes the clouds also paints the poles with curtains of green and violet light. Everything is connected, sky to sea, sea to stone, stone to flame. In the next part, we will explore these deeper connections, how the Earth's magnetic field dances with the solar wind to create auroras, how volcanoes and lightning share the same electric heart, and how the planet's restless energy shapes both beauty and disaster. Beyond the drifting clouds and gentle rains, the world hides deeper and rarer displays, flashes of power and beauty that remind us how alive our planet truly is. They are the rare moments when the forces of earth and sky meet in perfect tension, light against darkness, stillness against fury. They appear suddenly, vanish quickly, and leave behind the quiet awe that lingers long after. Among the most ethereal of these wonders are the auroras, the northern and southern lights. They are not storms, not clouds, but the visible language of the sun written upon the sky. Every aurora begins 93 million miles away on the blazing surface of our star. There, storms of magnetic energy hurl streams of charged particles, protons and electrons, into space. This solar wind drifts across the solar system, invisible, until it meets the Earth's magnetic field. When those particles reach us, the planet's magnetic shield guides them toward the poles, funneling them into the upper atmosphere. There, at heights of 100 kilometers and more, they collide with atoms of oxygen and nitrogen. The air itself begins to glow. Green, red, violet, and blue light ripple like curtains across the dark, waves of color that dance silently in the cold. Each hue tells a story: green from oxygen, red from high altitudes, blue from nitrogen. To see an aurora is to witness electricity made visible, magnetism made art. It flickers and flows, forming spirals, arcs, and ribbons that shift faster than thought. The Inuit once believed these lights were the spirits of ancestors playing in the sky. The Sami of the Arctic called them the fox's fire, sparks kicked up by a mythical creature running through snow. Even with science to explain them, auroras still feel sacred, not because they are mysterious, but because they make the invisible visible. Sometimes lightning dances not only within clouds, but from the ground itself. On rare occasions, storms give birth to a phenomenon known as sprites, flashes of red light high above thunderclouds, invisible from the ground unless the sky is perfectly clear. Sprites stretch like ghostly tendrils, reaching up toward space in silence. They last less than a heartbeat, but reveal that even the upper atmosphere hums with electricity. Above them, still higher, there are blue jets, narrow cones of light that shoot upward from thunderheads toward the stratosphere. These events are reminders that weather is not confined to where we live. It extends into the edge of space, where Earth's breath touches the void. At the opposite extreme, there is lightning born not from rain, but from fire. Volcanic eruptions can summon their own storms, plumes of ash and gas rubbing together, generating static charges so powerful they unleash bolts of electricity. Lightning strikes through smoke, illuminating clouds of molten dust. The sky glows with both fire and storm at once, a union of earth and air so fierce it feels ancient, primeval. These volcanic storms are not merely spectacle. They tell of nature's unity. The same physics that sparks in a thunderhead works in a mountain's roar. Static electricity, charge separation, sudden discharge, all part of the same cosmic principle. Energy seeks balance, and when imbalance grows too great, the universe releases it as light. Whether in a storm, a volcano, or the glow of an aurora, the story is the same: tension, release, beauty. Far beneath the sky, other forces move in silence until the moment they break free. An earthquake begins not with warning, but with waiting. For years, centuries, even millennia, stress builds in the Earth's crust as tectonic plates push and grind against each other. Then, without sound or signal, something gives. Rocks snap, fault lines slip, and waves of energy rush outward through stone, shaking the surface. When we feel an earthquake, we are sensing the movement of the planet's skin, a ripple in its slow rotation, a reminder that the ground beneath us is not still but drifting, floating on molten rock. Each quake, large or small, is part of the grand cycle of plate tectonics, the process that forms mountains, shifts continents, and shapes the ocean floors. Without it, Earth would be static, lifeless, a sealed shell instead of a breathing world. Sometimes, when oceanic plates collide or slide apart, the release of energy beneath the sea sends a shock through the water, a tsunami. The wave may begin invisibly, rising less than a meter high across thousands of kilometers. But as it approaches land, it grows taller, slower, stronger. A wall of water becomes a moving mountain. When it strikes, it changes coastlines, scours valleys, reshapes the world. And yet, even here, destruction carries creation. Nutrients from the deep sea spread across the land, renewing the soil for generations to come. Far above these waters, another immense power takes form in the warm breath of the tropics. A hurricane, a spiral of wind born from heat and rotation. It begins quietly, with air rising from a sunlit ocean. As warm water evaporates, it feeds the sky with moisture. The rising air cools and condenses, releasing heat that drives the storm further. The rotation of the earth twists the system into a swirl, and soon the wind begins to turn. With every hour, the spiral tightens, the air rushes faster, the pressure drops lower, and what began as a whisper becomes a force that can move oceans. At the heart of a hurricane lies its calmest place, the eye, a circle of eerie stillness surrounded by walls of fury. Within that eye, the air descends, clear and quiet, while all around it the storm roars. Rain falls in torrents, waves rise higher than buildings, and lightning flashes within walls of cloud that stretch 15 kilometers high. From above, satellites see these systems as perfect spirals, beautiful and terrible. They are the breath of the planet on a grand scale, energy moving from sea to sky, redistributing the heat of the tropics across the earth. Despite their destruction, hurricanes are part of balance. They cool the ocean's surface, stir nutrients upward, and shape coastlines. They remind us that energy cannot stay still. It must move, circulate, and change form. Without storms, the planet would overheat and stagnate. Nature's violence, in the largest sense, is also its therapy. Other natural displays come not from movement of rock or wind, but from chemistry and light. The mysterious St. Elmo's fire, for instance, is not fire at all, but glowing plasma. When a storm's electric field becomes intense, it can cause air molecules around sharp points, the mast of a ship, the tip of a church steeple, even the wings of an airplane, to ionize and emit light. A ghostly blue flame appears, flickering silently. Sailors once saw it as a blessing, a sign that their ship was protected. Scientists see it as a whisper of lightning's power, a soft echo of the storm's unseen charge. And then there are the lights of the desert, faint, flickering orbs that drift across arid plains. Known by many names, will-o'-the-wisps, ghost lights, Fata Morgana, they are illusions born of temperature and air. When layers of hot and cold air bend light in just the right way, distant objects appear to float or shimmer. Ships seem to sail above the horizon. Mountains hover in midair. A simple trick of refraction becomes a mirage, a vision of something that is not there, made from the bending of reality itself. In the polar regions, another wonder graces the long winter nights, light pillars. When the air is perfectly cold and filled with flat ice, crystals light from the ground, street lamps, moonlight, or even a single candle reflects upward, forming tall columns of brilliance that stretch into the sky. They look like frozen beams, solid and silent, connecting Earth to the heavens. Unlike rainbows or auroras, light pillars are born not from movement, but from stillness. from ice hanging motionless in the air, waiting to catch the light. Some phenomena are so rare they seem like secrets whispered by the planet. Ball lightning, glowing spheres that sometimes appear during storms, remains one of science's great mysteries. They drift slowly, flicker, and vanish without sound, sometimes passing through walls or leaving the scent of ozone. No one fully understands them. Some theories suggest plasma, others chemical reactions in the air. Perhaps they are the sky's dreams, a brief echo of lightning refusing to fade. There are rains of strange things, fish, frogs, even stones, carried aloft by waterspouts or tornadoes and released far from where they began. There are fire whirls, spinning pillars of flame that rise from wildfires, twisting like living creatures. There are dust devils in deserts and ice circles spinning in frozen rivers. The earth performs 1,000 small miracles every day, unseen by most, unnoticed by many. Even quiet light has its wonders. During calm nights over the ocean, the sea itself can glow. Tiny plankton, disturbed by waves or motion, release light through bioluminescence. Each flash is a chemical reaction, oxygen, luciferin, enzymes, producing a cold blue radiance. As ships pass, they leave glowing trails. As waves break, their crests shine. It is as though the stars have fallen into the water. This same gentle light appears in tropical bays, where swimmers can see their own hands surrounded by galaxies of blue sparks. Every phenomenon, from auroras to earthquakes, from hurricanes to tsunamis, from lightning to mirages, reminds us that nature is both artist and engineer. It works with forces we barely grasp, balancing energy and matter in infinite forms. Nothing is random. Even the most chaotic storm follows rules older than life itself. To watch these things is to witness creation in motion. The planet is not still. It dreams, shifts, breathes, and flashes with light. Every gust of wind, every flicker of lightning, every trembling of the ground is part of a single grand design. In the next part, we will descend deeper into that design, exploring how the forces of the sun, the oceans, and the rotation of the earth combine to create the endless dance of weather systems, from monsoons to hurricanes, from the calm eye of a storm to the quiet snow falling in the dark. The air that moves above us is not confined to one place. It flows like blood through the veins of the planet, rising and falling, looping endlessly between ocean and land, pole and equator. The weather we feel at our window is part of something vast, an invisible circulation that wraps the entire earth. Each gust of wind, each gentle rain, each distant storm is a thread in that great tapestry of motion. The source of this motion is the sun, but the pattern belongs to Earth. The planet spins, tilts, breathes, and dreams, and in doing so, it creates the seasons and the winds. Warm air from the equator moves toward the poles, while cold air from the poles flows back toward the equator. But because the planet rotates, these currents do not travel in straight lines. They twist into great spirals, belts of trade winds, westerlies, and polar streams, forming a global ballet of air. High above, near the top of the atmosphere, jet streams race around the world at hundreds of kilometers per hour. These narrow rivers of air steer weather systems, carrying storms across oceans, shifting heat and cold between continents. A change in the jet stream's path can alter the climate of entire regions, bringing drought to one place and flood to another. Closer to the ground, other great cycles breathe in time with the seasons. One of the most powerful is the monsoon, a pulse of air and water that defines life for billions of people. The word comes from the Arabic mausim, meaning season. In summer, as the land heats faster than the ocean, warm air rises over continents, drawing moist winds from the sea. The result is rain, not a drizzle, but vast, life-giving downpours that fill rivers, flood fields, and paint the landscape in green. When the rains come, the world transforms. In India, in Southeast Asia, in Africa, the monsoon is not just weather, but rhythm, faith, and survival. Crops depend on it, rivers swell because of it, and entire cultures are shaped around its arrival. People listen for its signs, a change in the wind, the scent of damp earth, the low grumble of distant thunder. The monsoon does not arrive suddenly. It builds, breath by breath, until the first raindrops fall and the waiting world exhales. Then, months later, it retreats. The winds reverse, blowing cool and dry air out to sea. Fields rest, skies clear, and a quiet balance returns. The monsoon, like the heartbeat of the planet, never truly ends. It only sleeps until the next awakening. But not all global cycles are so gentle. Far out in the Pacific Ocean, another rhythm stirs, slower, subtler, yet capable of changing the weather across half the world. It is called El Niño. Every few years, the winds that normally push warm water westward weaken. The ocean responds by shifting its warmth eastward toward the coasts of South America. This change in temperature may seem small, only a few degrees, but it reshapes the entire planet's climate. When the Pacific warms, rains that usually fall over Indonesia and Australia drift east, leaving drought behind. Meanwhile, the normally dry coasts of Peru and Ecuador experience floods. Farther away, storms strengthen, winters change, and distant continents feel the echo of that oceanic pulse. El Niño has a twin, La Niña, when the winds strengthen instead, pushing warm water westward, cooling the eastern Pacific, and reversing the pattern. Together, they form the El Niño Southern Oscillation, a vast breathing of the ocean and atmosphere, repeating every few years, unpredictable but powerful. Scientists call it a teleconnection, a link across distance, but to think of it simply as cause and effect misses its poetry. The truth is more beautiful. The planet listens to itself. A shift of wind in the Pacific can change rainfall in Africa or winter storms in North America. The world is one great system, always in conversation. Another part of that conversation flows invisibly through the air. Atmospheric rivers. These are long, narrow bands of moisture that stretch for thousands of kilometers, carrying more water than the Amazon River, not in liquid form, but as vapor. When they reach land and rise over mountains, the moisture cools and falls as heavy rain or snow. California, Chile, Portugal, and New Zealand all owe much of their rainfall to these hidden streams in the sky. They are the sky's own waterways, linking the oceans to the continents, feeding forests and rivers below. Sometimes these atmospheric rivers grow too strong, and the rains they bring become floods. Yet without them, many lands would dry and wither. Even in their extremes, they are part of balance, the ceaseless exchange between ocean and sky. Beyond these cycles lie the trade winds, the steady currents that once carried ships across the world. In the age of sail, navigators learned to trust them. The easterly winds near the equator, the westerlies farther north and south. These winds are born from the planet's rotation and the heat of the tropics, spinning gently around the earth like threads of an endless loom. Without them, the oceans would stagnate, the weather would lose its rhythm, and life as we know it would change. At the poles, air sinks and flows outward, meeting warmer air along boundaries called polar fronts. Here, storms are born. Waves of cold and warm air spiral together, forming low-pressure systems that travel across continents. They are not chaos, but the Earth's way of mixing, balancing, sharing energy. Each storm, each front, is a breath, an inhale and exhale of the atmosphere. Even the calm days are part of this motion. A still afternoon in one part of the world may mean that air is quietly rising elsewhere, preparing clouds beyond the horizon. Every weather pattern is connected. The breeze that cools your face may be the distant sigh of a storm halfway across the ocean. Deep beneath these patterns lies another influence, the rotation of the Earth itself. Because the planet spins, moving air curves to the right in the northern hemisphere, to the left in the southern. This effect, known as the Coriolis force, shapes cyclones and trade winds alike. Without it, hurricanes would not spiral, jet streams would flow straight, and the entire global system would lose its elegance. Even the color of the sky, that endless blue we take for granted, is part of the story. Sunlight scattering through air gives us day and twilight, sunrise and sunset. When dust or moisture fills the sky, the light bends differently, painting the heavens with gold or crimson. The same light that drives the weather also gives it beauty. The weather does not exist apart from life. It is life's foundation. Plants breathe carbon dioxide from the air. Rain nourishes them. Wind carries their seeds. Animals migrate with the seasons, guided by invisible patterns of pressure and temperature. Even the movements of humanity, where we live, what we grow, how we travel, are shaped by the mood of the sky. To study weather is to read the diary of a living planet. Each page is written in cloud and wind, in rain and lightning, in drought and flood. The handwriting changes, but the story remains the same. The Earth striving for balance, always in motion, never truly at rest. And sometimes, when all these systems align, we witness events of breathtaking magnitude, perfect storms where ocean heat, air rotation, and global pressure weave together into something almost sentient. The hurricane that spins across the sea, the monsoon that feeds entire civilizations, the river of air that crosses oceans, they are all notes in the same melody. In the next part, we will travel deeper into the heart of that melody, exploring how weather shapes life itself, how animals predict storms, how forests create rain, and how even the smallest changes in air can ripple through the web of existence across the globe. The weather is not only something that happens to life, it is something life helps to create. Every breath of wind, every drop of rain, every mist that rises from the forest carries within it the traces of living things. The atmosphere is not merely air, it is a living archive of respiration, growth, and decay. Plants are the quiet architects of weather. Each leaf is a gate, opening and closing to balance the exchange of air and water. Through photosynthesis, plants draw in carbon dioxide and release oxygen, the very air we breathe. But they also exhale water vapor, an invisible breath that rises into the sky. Billions of trees across rainforests, savannas, and mountains release moisture every day, forming vast clouds that drift over continents. The Amazon, for instance, creates half of its own rainfall. The forest feeds the sky, and the sky feeds the forest in return. When the morning sun warms a jungle canopy, tiny openings on each leaf, stomata, begin to open. Water evaporates through them, carrying with it the faint scent of life. That vapor rises, cools, and condenses into clouds. By afternoon, the sky darkens, and rain falls again on the same trees that gave birth to the clouds. This is the forest's heartbeat, a daily cycle of giving and receiving, an endless loop of life and weather. Even in the oceans, living things shape the air above them. Microscopic algae called phytoplankton drift in sunlight, producing oxygen and releasing tiny particles of sulfur compounds. When these reach the atmosphere, they become seeds for clouds around which droplets form. In this way, invisible organisms in the sea help decide when and where it will rain on land. The ocean and sky are bound by chemistry and breath. Animals, too, are part of this grand system. When billions of insects take flight, their wings stir the air in subtle waves. The migration of birds alters patterns of air currents. Even herds of grazing animals change how sunlight reflects off the ground, influencing local temperatures. A single thunderstorm, it turns out, can depend on the heat released by a forest full of life. In Africa, great herds of wildebeest and zebra shape weather simply by moving. Their hooves churn the soil, releasing nutrients that feed plants, which in turn release water vapor and carbon dioxide. Grasslands breathe with them, clouds form above them, and the rains follow their paths like a patient companion. The connection runs deeper still. In the Arctic tundra, mosses and lichens hold the cold, reflecting sunlight back into space and keeping permafrost frozen. In the tropics, dark green forests absorb light and warmth, creating low pressure that draws moist air inland. Life is the painter, and the climate is its ever-changing canvas. Microbes, unseen but powerful, are also part of this story. In the soil beneath your feet, countless bacteria and fungi digest fallen leaves, releasing carbon dioxide, methane, and other gases. These invisible exchanges regulate the composition of the atmosphere itself. Without them, Earth's air would drift out of balance. Every breath we take is filtered, shaped, and balanced by the work of tiny beings we will never see. Even coral reefs, those underwater cities of stone and color, influence the air above. They absorb carbon from the sea, store it in their skeletons, and release compounds that rise into the sky, helping form clouds. The reef, the ocean, and the weather are all chapters of one long, fluid story. Life responds to weather, but it also anticipates it. Before storms, animals grow restless, birds change their flight paths, cows lie down in fields, frogs begin to sing, and insects vanish into the soil. Science has found that many species can sense changes in air pressure long before we can. A drop in pressure warns of rain or wind. Even fish beneath the surface adjust their depth, moving to calmer waters before a storm arrives. Some animals use weather as a compass. Migrating birds follow invisible highways in the sky, guided not only by stars and magnetism, but by the steady flow of the jet streams. Monarch butterflies, light as paper, cross continents on air currents that shift with the seasons. Whales, deep beneath the waves, follow. Temperature gradients in the ocean, subtle traces of heat shaped by winds thousands of kilometers away. And just as life adapts to weather, it helps to create microclimates, small, unique worlds where conditions differ from their surroundings. A forest glade may be cooler and more humid than the open plain beside it. A city with its dark roofs and concrete may hold more heat than the countryside, forming an urban heat island. These contrasts influence wind, rain, and temperature on scales both small and vast. The air above a meadow and the air above a metropolis live side by side but breathe differently. Even a single tree can shape the climate around it. Beneath its branches, the air cools and slows. Roots draw up moisture, leaves shade the ground, and birds spread seeds that will one day grow into new trees. Each one adds to the invisible architecture of weather, the collective exhale of the living world. At larger scales, forests are Earth's lungs, oceans its heart, and the atmosphere its voice. They speak to each other in slow, patient cycles, carbon traded for oxygen, heat for rain, light for growth. destroy one, and the others falter. Restore them, and the balance returns. Yet the connection between life and weather is not only physical, it is emotional, cultural, and spiritual. For as long as humans have existed, we have read meaning in the sky. Farmers once measured clouds to predict harvests. Sailors read winds to find their way home. Ancient peoples told stories of gods who ruled thunder and rain, who punished with drought or blessed with gentle weather. Even now, we describe moods in the language of the sky: bright days, stormy tempers, calm minds. Weather has always been a mirror of the soul. In every culture, rain carries emotion. It cleanses, renews, mourns, and celebrates. Sunlight brings life, but also drought. Snow covers the world in silence, yet promises rebirth in spring. The cycle of weather mirrors the rhythm of human feeling: calm and chaos, heat and cold, drought and flood. It reminds us that emotion too is a kind of weather within us, a storm that rises, rains, and clears. Some of the planet's most complex weather patterns exist only because of life's presence. Forests create rain, oceans breathe clouds, grasslands moderate heat. The air we feel on our skin has passed through the leaves of trees, the gills of fish, the breath of animals. In every sense, we live inside the shared exhalation of the biosphere. Even in death, life feeds the weather. When leaves fall and decay, when forests burn and regrow, when volcanoes release nutrients that later nourish the sea, each event becomes part of the atmospheric balance. The carbon released by one generation is used by the next. The cycle never stops, it only transforms. In the high canopy of the rainforest, scientists have discovered microbes that live in the clouds themselves, tiny organisms carried aloft by rising air, surviving in the cold, seeding new droplets. They may help shape rainfall, turning life into weather, and weather back into life. The boundary between the two grows softer the closer we look. All of this reminds us that weather is not just an external phenomenon, it is an echo of life itself, the planet's collective breathing, visible in the play of light and shadow above us. In the next part, we will explore the hidden moods of the planet, the cycles of drought and flood, of warmth and cold that shape history and civilization. We will see how small changes in the air can reshape forests, rivers, and empires, and how the whisper of wind can become the story of an age. The weather we know, the daily rhythm of clouds, wind, and rain, is only the smallest note in a vast and ancient symphony. The true story of Earth's climate is written not in days or years, but in millennia. It moves slowly, like breath drawn in over eons, released over ages. There are moments when the planet exhales warmth and life flourishes across continents, and others when it inhales cold, wrapping the world in ice. These are the great cycles of climate, the deep rhythms beneath the surface of ordinary weather. Long before there were cities or names for the months, the Earth moved through immense transformations. Ice once covered most of the planet, thick sheets kilometers deep stretching across the northern hemisphere, carving mountains, grinding valleys, and locking the seas into frozen silence. These were the Ice Ages, when vast glaciers advanced and retreated in slow motion, breathing with the planet's tilt and orbit around the sun. The cause was not one thing, but a combination of subtle cosmic mechanics: the way Earth wobbles on its axis, the shape of its orbit, the angle of its tilt. These slow cycles, called Milankovitch cycles, alter how sunlight reaches different parts of the world. When less sunlight warms the poles, snow and ice reflect more light back into space, cooling the planet even further. When sunlight increases again, the ice retreats, the The planet breathes in cold, breathes out warmth. During the height of the last ice age, about 20,000 years ago, much of North America and Europe lay beneath glaciers thicker than mountains. Sea levels were more than 100 meters lower than today. The world's coastlines were different. Ancient land bridges connected places now separated by ocean. Mammoths and woolly rhinoceroses wandered across frozen plains, and human beings followed them, hunting, adapting, learning to survive in the long winters. And then, slowly, the ice began to melt. The air warmed, the seas rose, and forests spread northward again. Rivers carved new paths, carrying glacial melt into the oceans. The world changed shape, and with it, human life changed too. People settled, planted, and built. Civilization itself, farming, cities, language, art, arose in a rare moment of climate calm, a brief and precious intermission between extremes. That calm, which began roughly 12,000 years ago, is called the Holocene. It has been a time of relative stability, warm enough for crops, wet enough for rivers, steady enough for life to flourish. All the history we know, from the pyramids to the present day, fits within this single, gentle window of weather. But even in stability, the Earth continues to shift. Its patterns of warmth and dryness, flood and famine are never still. Civilizations have always risen and fallen with the climate. When rains are kind, rivers swell and fields grow rich. When the sky turns dry, kingdoms crumble. The ancient Sumerians of Mesopotamia built canals to tame the unpredictable floods of the Tigris and Euphrates. The Mayans of Central America flourished under steady monsoon rains until drought arrived. Within a century, their great cities were abandoned, their temples swallowed by forest. In Egypt, the rhythm of the Nile was once a calendar of life. A failed flood meant hunger, a great one meant renewal. Even now, in our modern world, the pattern continues. We build our lives around climate, often forgetting that it does not belong to us. A shift in temperature by only a few degrees can change the boundaries of forests, the migration of fish, the timing of crops. The planet is always speaking. It is we who sometimes forget to listen. Throughout history, there have been times when climate has changed quickly, reshaping entire eras. About 4,100 years ago, a sudden global drought struck, rivers shrank, harvests failed, and empires in Egypt, Mesopotamia, and the Indus Valley faltered almost simultaneously. No single cause explains it fully, perhaps a shift in monsoon winds or volcanic dust veiling the sun. But the pattern is unmistakable. The world cooled and humanity changed with it. Even in more recent centuries, climate has left its mark. Between the 14th and 19th centuries, much of the world endured what scientists call the Little Ice Age. Glaciers advanced once more, winters grew long and harsh, and crops failed across Europe and Asia. Painters of that time captured frozen rivers and gray skies, unaware they were documenting a small echo of the planet's greater breathing. And then, as always, the pendulum swung again. The air warmed, the ice retreated, and the modern climate, the one we know, emerged. But this time, something was different. The warmth was no longer only nature's doing. Humanity, in its search for power and comfort, had begun to alter the balance. When we burn coal, oil, and gas, we release carbon that has been buried for millions of years. Those invisible molecules rise into the air, trapping heat that would otherwise escape into space. It is the same principle that makes Earth livable, the greenhouse effect, but amplified. The planet is warming faster now than at any time in recorded history. Glaciers melt, seas rise, Storms grow stronger and ancient patterns shift before our eyes. Yet even this change fits within the grand rhythm of nature: energy, balance, transformation. The difference now is speed. Where once the Earth took centuries to shift by a degree, it now happens in decades. Life can adapt, but not always fast enough. Forests migrate northward too slowly, coral reefs bleach in warmer seas, and animals search for climates that no longer exist. But even here, there is still wonder. The forces we awaken remind us of how intertwined we are with the world. The air we breathe today may once have passed through the lungs of ancient creatures. The rain that falls on a city tonight may contain water once locked in ice during the last glacial age. The cycles of warmth and cold, flood and drought are the pulse of a planet that is alive, not in body, but in process. And deep beneath these shifting patterns, there is always renewal. When ice retreats, it leaves behind fertile soil. When deserts expand, new species arise to fill them. The balance of the earth is not a line, but a dance, sometimes harsh, sometimes graceful, always moving. Life does not resist change, it flows with it. The great ice ages may seem distant, but their echoes live on in the shape of our world. The valleys we inhabit were carved by glaciers. The rich black soil of plains was ground from stone by ice. Even the rivers that flow today often trace the paths of melted glaciers. The fingerprints of ancient weather are everywhere. And just as the past shaped the land, the future will reshape it again. Scientists predict that the Greenland and Antarctic ice sheets are slowly melting. If they were to vanish completely, sea levels would rise by tens of meters, redrawing coastlines, swallowing cities, and creating new shores. Islands would disappear, but new bays would form. The map of Earth would change again, as it has so many times before. Even the air itself will continue to evolve. As temperatures rise, winds may shift, altering where deserts and rainforests lie. The monsoons may come earlier or later, storms may reach new latitudes. The climate, once a steady companion, may become more unpredictable, not out of malice, but out of balance. The Earth is not angry, it simply responds. And yet, for all its power, the atmosphere is fragile, a film of gas only a few dozen kilometers thick, thinner relative to the planet than the skin of an apple. Everything we know, every storm, every breeze, every breath, happens within that delicate layer. It is both our shield and our cradle. We often think of climate as something vast and beyond us, but in truth, it is intimate. When you breathe out, the carbon from your lungs joins the global cycle. When you plant a tree, its leaves become part of the sky. Each small act of destruction or care ripples through the system. The Earth remembers. The cycles of weather and climate are not merely scientific, they are stories of resilience. The planet has frozen and thawed, burned and healed again and again. Each time life found a way, not the same life, but new forms, new patterns. The forests and oceans of today are descendants of survivors, shaped by storms and seasons, stretching back to the dawn of time. In the next part, we will journey into the frontiers of weather itself, to the edges of storms and the calm within them. We will explore tornadoes, blizzards, and sandstorms, the sculptors of landscape and memory, and see how even the fiercest tempest can hold a strange and solemn beauty. There are moments when the sky no longer whispers, it roars. Moments when the balance of air and earth breaks and raw power takes shape in motion. These are the tempests, tornadoes, blizzards, sandstorms, and lightning storms, the extremes of weather that reveal the planet's wild heart. Yet even in their fury, there is structure, purpose, and beauty. The world is never cruel, it is simply alive. Let us begin with the tornado, nature's most concentrated storm. It begins quietly, hidden inside a towering thundercloud. As warm, moist air rises from the ground, it meets cooler, drier air above. The two layers slide past one another, and somewhere in the invisible boundary between them, the wind begins to twist. A column of rotation forms, stretching upward, feeding on the storm's energy. Inside that invisible spiral, air moves faster and faster, forming a vortex, a tube of rotating wind that can reach speeds over 300 kilometers per hour. Then, suddenly, the funnel touches the ground. Dust, debris, and rain wrap around it, giving it shape. What was once invisible becomes a living form, a column of shadow and motion, spinning with the force to uproot trees, lift cars, and tear houses apart. Yet, when viewed from afar, it is strangely elegant. The tornado moves with precision, its funnel tapering to a point, its base twisting like a dancer's ankle. The air around it hums with static charge, a low, trembling growl that vibrates through the earth. Inside, pressure drops so suddenly that water in the air condenses instantly, giving the vortex its ghostly gray body. And then, as quickly as it came, it vanishes. The funnel thins, unravels, and dissolves back into the cloud. What remains is silence, an eerie calm, as if the world itself is catching its breath. Tornadoes are short-lived, most lasting only minutes, but in that brief span, they remind us how delicate the balance of air truly is, how easily order can turn to chaos, and how quickly chaos returns to stillness. Tornadoes belong to the flatlands, but their cousins, tropical cyclones, typhoons, and hurricanes, belong to the sea. Each begins as a whisper of wind over warm water. When the ocean's surface heats above 26 degrees Celsius, it begins to feed the sky. Moist air rises, cools, and condenses, releasing heat. That heat fuels more rising air, more condensation, more wind. The spiral begins, shaped by Earth's rotation, tightening as it grows. At first, it is a tropical depression, a cluster of storms feeding on shared warmth. Then it becomes a tropical storm, and finally, a hurricane. Inside its vast circular wall, air rushes upward in a column hundreds of kilometers wide. Rain falls in sheets so dense that day turns to night. The ocean itself rises, forming walls of water, storm surges that crash against the shore. And yet, at the heart of this chaos lies the eye, a perfect circle of still air, often clear and silent, surrounded by the most violent winds on Earth. In that eye, the sea is smooth, the clouds open like a ringed cathedral, and sunlight filters down through the towering walls of vapor. It is one of nature's strangest paradoxes, calm born from violence. Hurricanes, despite their destructive power, are part of the planet's cooling system. They carry heat from the tropics toward the poles, redistributing energy, equalizing temperature. They are not accidents, but instruments of balance. When we look at them from space, they appear almost serene, perfect spirals of white cloud turning slowly over a blue world. From warm seas, we move to frozen lands. The blizzard is the voice of winter in its purest form. It begins with cold air so heavy it falls like liquid. Moisture from the sea or a lake feeds into it, and snow begins to form, not as flakes yet, but as crystals in the clouds. Each grows around a particle of dust, building arms of ice in symmetry so fragile it seems impossible they survive the fall. But they do. When winds rise and temperatures drop, snow becomes something else entirely, not a gentle drift, but a storm of frozen needles. A blizzard erases distance, swallowing sound, color, and direction. In its heart, the world disappears. Travelers of the Arctic describe it as stepping into whiteness so complete that the ground and sky become one. The air bites, the cold thickens, and time itself seems to slow. But even this fury has a strange beauty. The way snow drifts and folds under wind creates patterns like sand dunes, curves of soft geometry shaped by invisible fingers. In the silence after a storm, the world glows, light scattered through billions of tiny crystals, turning every branch and rooftop into a sculpture. Where cold and heat meet, other storms arise. In the deserts, sandstorms sweep across the horizon, carried by winds that span entire continents. A wall of dust climbs into the sky, blocking the sun, turning day into twilight. The particles are so fine that they stay suspended for hours, sometimes days, traveling thousands of kilometers before settling. From the Sahara, sand crosses oceans. Dust from Africa feeds the Amazon rainforest, rich in iron and phosphorus. What seems like destruction, choking winds, blinding skies, is in truth part of a cycle of nourishment. The desert feeds the jungle returns moisture to the air. Nature's balance does not judge, it simply moves what needs to move. In other parts of the world, storms of a different kind take shape. Hail, ice born from turbulence, forms inside powerful thunderclouds. Within those clouds, air currents rise and fall in great spirals. Droplets of water are lifted high into freezing layers, where they freeze, fall, and are lifted again, gathering more layers of ice each time. When the hailstones grow too heavy for the updrafts to carry, they fall. Stones of frozen rain that rattle against roofs and fields. Each hailstone tells the story of its own creation. Slice one open and you'll see rings, layers of ice like tree growth rings, a record of its journey through the cloud. Some grow small as pearls, others as large as apples. Their fall is brief but fierce, a percussion of ice that can strip leaves, dent metal, and then melt quietly into nothing. And above all these storms, lightning reigns as the most elemental of phenomena. Inside a thundercloud, droplets, ice, and dust collide endlessly, building up electric charge. The top of the cloud becomes positive, the bottom negative. When the difference becomes too great, the sky itself breaks down and a current leaps through it, a flash so bright it lights the horizon. A bolt of lightning is hotter than the surface of the sun, yet it lasts only a fraction of a second. The light travels first, the thunder follows, rolling through the air like the voice of the storm. It is the Earth's oldest music, the same sound our ancestors heard when the world was young. There are many forms of lightning: the quick fork that leaps from cloud to ground, the sheet lightning that flickers inside the cloud itself, the ball lightning that drifts mysteriously through the air. And above them all, high in the stratosphere, red sprites and blue jets flash like silent ghosts. Lightning connects the ground to the heavens, a thread of fire stitching sky and earth together. In all these tempests, tornadoes twisting, hurricanes spinning, blizzards howling, lightning striking, there is order hidden within chaos. Every movement follows laws of heat, motion, and balance. The violence of the storm is not destruction alone, but transformation, energy shifting from one form to another, always returning to calm. When the storm ends, the silence that follows feels almost sacred. The air smells of rain, of dust, of ozone. The world is washed clean, its edges softened. Storms remind us that peace and power are not opposites, but companions. The sky must empty itself before it can clear. In the next part, we will step beyond the immediate storms and look into the subtle atmospheres of other worlds, the weather on planets beyond our own. We will travel through the burning winds of Venus, the frozen tempests of Neptune, and the eternal storms of Jupiter, discovering how weather continues far beyond the blue horizon of Earth. Beyond the blue curve of our world, weather continues. It does not stop where the sky fades into space. It only changes form. The planets of our solar system each carry their own atmospheres, their own tempests, their own seasons of silence and storm. Though none are like Earth, all are governed by the same laws of physics: heat, pressure, motion, and light. And together they form a gallery of alien skies, each one telling a different story of what weather can be. Let us begin close to home with Venus, the twin that became a stranger. In size and gravity, Venus is nearly Earth's mirror image, yet its atmosphere is a world apart, dense, toxic, and crushing. Clouds of sulfuric acid fill the sky, lit by the constant glow of lightning that flickers through the haze. The air is so thick that winds high above move faster than sound would travel through water. These winds circle the entire planet in just 4 Earth days, dragging the clouds in endless rotation. But below that furious sky, the surface is almost still. The dense atmosphere acts like a blanket, trapping heat so effectively that the ground temperature reaches over 460 degrees Celsius, hot enough to melt lead. It is the ultimate greenhouse world, a reminder of what happens when a planet forgets to breathe out its heat. On Venus, rain never reaches the ground. The droplets of acid evaporate before they fall. The planet is locked in perpetual twilight, where day and night blur together under a sky of golden fire. Next, we travel outward to Mars, a world of dust and memory. The Martian sky is thin, tinted pink by the fine dust that floats in its air. The atmosphere is less than 1% as dense as Earth's, yet it still breathes with motion. Each spring, as sunlight warms the frozen poles, carbon dioxide turns directly into gas, creating winds that sweep across the planet. These winds lift dust into the air, not in gentle drifts, but in vast storms that can engulf the entire world. A global dust storm on Mars is unlike anything on Earth. From orbit, the planet vanishes beneath a swirling veil of ochre. Sunlight fades, temperatures drop. For weeks or months, the surface is lost in shadow. When the storm finally clears, the red plains are smoothed clean, their scars softened. In this thin, alien air, weather is quiet but persistent, sculpting dunes, eroding craters, and carrying whispers of an atmosphere that once might have held rivers and rain. Mars may seem dead, but its weather is still alive in miniature. Frost that blooms on the rocks before dawn, whirlwinds of dust that dance across the plains, ice clouds that shimmer above extinct volcanoes. Even in its silence, Mars dreams of wind. Farther from the sun lies Jupiter, the giant of storms. Here, weather becomes pure energy, an ocean of gas with no solid surface, only layers upon layers of cloud and lightning. Jupiter's atmosphere is composed mostly of hydrogen and helium, but mixed within are bands of ammonia, water, and other gases that paint its sky in streaks of white, beige, and crimson. Across its face swirls the Great Red Spot, a storm so large it could swallow Earth whole. It has raged for centuries, possibly millennia, spinning counterclockwise in an endless whirl. The winds inside it reach over 400 kilometers per hour, and yet it remains stable, as though time itself forgets to touch it. Around it, smaller storms collide and merge, birthing new vortices, like the pulse of a living giant. Lightning on Jupiter is fierce beyond imagining, bolts dozens of times stronger than any on Earth, lighting up clouds thousands of kilometers thick. The sound, if it could travel through that dense air, would be deafening. But beyond the violence lies beauty. Delicate veils of auroras shimmer at Jupiter's poles, caused by the same solar wind that paints Earth's skies. The auroras of Jupiter are permanent, glowing endlessly in the magnetic embrace of its field. Next comes Saturn, the Lord of rings and storms. From afar, its golden atmosphere looks calm, but up close, it seethes with hidden energy. The winds on Saturn are faster than anywhere else in the solar system, up to 1,800 kilometers per hour. Bands of cloud race endlessly around the planet, and once every few decades, a storm erupts so vast it wraps the planet in white. These great white spots are rare tempests fueled by heat rising from deep within, releasing energy stored for years. Near Saturn's North Pole spins one of the strangest phenomena in the solar system, the hexagon. It is a vast six-sided storm, larger than Earth, rotating steadily for at least 40 years. Scientists believe it is formed by standing waves in the atmosphere, yet no other planet shows anything like it. Within that geometric vortex, the winds swirl in perfect symmetry, a mathematical storm, a shape carved from air. Beyond Saturn, Uranus drifts in icy silence. Its atmosphere is pale blue, tinted by methane gas that absorbs red light. Uranus lies on its side, tilted more than 90 degrees, so its poles take turns facing the sun for decades at a time. This strange orientation creates seasons that last more than 20 Earth years, long winters of twilight, long summers of endless dawn. For most of its orbit, Uranus seems calm, but sometimes immense storms burst forth, flashing across its surface in bright white plumes. These tempests are fueled not by sunlight, too weak at that distance, but by internal heat deep within the planet's icy heart. And then there's Neptune, the farthest known world of our family, dark, cold, and fiercely alive. Despite receiving only a fraction of the sunlight that warms Earth, Neptune has the most violent winds in the solar system. They scream across its surface at speeds over 2,000 kilometers per hour, faster than the speed of sound on Earth. The cause is a mystery. Perhaps it is internal heat rising from within. Perhaps it is the chemistry of its deep, icy atmosphere. Whatever the reason, Neptune is a paradox, a world of freezing calm and unimaginable motion. Like Jupiter, it too bears great storms, ovals of dark blue that come and go, forming and dissolving over years. The largest, once called the Great Dark Spot, was seen by the Voyager spacecraft in 1989. When later telescopes looked again, it was gone, replaced by others, new tempests born from the same restless air. Even at the edge of the sun's warmth, weather endures. Between these worlds lie countless smaller bodies, moons, comets, asteroids, each with its own kind of atmosphere, or none at all. On Titan, Saturn's largest moon, rain still falls, but it is not water. It is liquid methane flowing through valleys and lakes under a thick orange haze. On Io, Jupiter's volcanic moon, sulfur erupts in plumes that rise hundreds of kilometers high. Even Pluto, once thought inert, shows traces of an atmosphere that freezes and sublimates with the seasons, creating delicate frosts of nitrogen and methane. Across the solar system, weather takes forms we can barely imagine. Storms of metal on exoplanets so hot that iron rains from the sky. Winds on distant brown dwarfs that whip clouds of molten rock. Lightning in the methane clouds of Titan. And icy snow made of carbon dioxide on Mars. The laws are the same everywhere. Heat moves to cold, pressure seeks balance, but their expression is infinite. Looking outward, we see not alien worlds, but mirrors, reflections of our own atmosphere in other forms. Venus shows what happens when the greenhouse effect runs wild. Mars shows what happens when it fades away. Jupiter and Saturn show us how energy moves in giants, and Neptune shows us that even in the farthest cold, motion persists. All of them, together, remind us that weather is not a quirk of Earth, but a universal truth. Where there's air, there's motion. Where there's motion, there's weather. The universe itself is a vast storm, swirling with energy and light. In the next part, we will return home to explore the invisible edges of Earth's weather, the jet streams, the auroras, the magnetic field, and the upper atmosphere where our world touches space. There, we will find the bridge between the blue sky we know and the black infinity beyond. Above the clouds, beyond the reach of ordinary storms, the sky begins to change. The blue deepens, the air thins, and weather, as we know it, begins to dissolve into something stranger. Here, in the upper atmosphere, the familiar rhythms of rain and wind give way to the delicate forces that shape the edge of our world. It is a place of silence and light where invisible currents flow endlessly, connecting the earth to space itself. The atmosphere is not one smooth blanket of air. It is layered like an ancient ocean turned upright. The lowest layer, the troposphere, is where we live, where clouds form, winds blow, and almost all weather unfolds. Above it lies the stratosphere, calm and still, where temperature rises with height instead of falling. Higher still are the mesosphere, the thermosphere, and finally, the exosphere, where the last atoms of air drift away into the void. Each layer has its own personality, its own kind of weather. In the stratosphere, about 10 kilometers above the ground, the air is so thin that clouds rarely form, but when they do, they are unlike any others. These are the polar stratospheric clouds, sometimes called mother-of-pearl clouds. They shimmer in pastel colors, pink, green, violet, glowing softly in the twilight after the sun has set. Their beauty hides a fragile truth. They form in the bitter cold of polar winter at temperatures below 80°C. Even higher, in the mesosphere, there are clouds that glow at night, noctilucent clouds. They are the highest clouds on Earth, hanging more than 80 kilometers above the surface. Made of tiny ice crystals, they catch sunlight long after the ground below has grown dark. To see them is to glimpse the border between day and night, Earth and space, silver threads woven into the dusk. But the most breathtaking light of all appears near the poles, the auroras. They are the sky's silent symphony, ribbons of green, violet, and crimson dancing across the darkness. Though they look like living fire, they are made of invisible energy. Streams of charged particles from the sun, carried by the solar wind, strike Earth's magnetic field and spiral down toward the poles. As they collide with atoms of oxygen and nitrogen in the upper atmosphere, those atoms release light, shimmering curtains that sway and ripple like fabric in an unseen breeze. Each color has its origin. Green comes from oxygen about 100 kilometers up, red from oxygen higher still, purple and blue from nitrogen glowing in thin air. The auroras move soundlessly, though observers often say they seem to whisper. In the far north, some legends once claimed that the lights were the souls of the departed, dancing above the world. In the far south, travelers called them the breath of the gods. The aurora is more than beauty. It is a map of invisible forces. Earth is surrounded by a magnetic field born from molten metal swirling in its core. This field shields us from the storm of radiation that flows from the sun, bending those charged particles away. Without it, our atmosphere would be stripped away over time, as happened to Mars. The field is invisible, but its strength is painted into the sky every time the aurora dances. It is the Earth's heartbeat made visible. Sometimes, however, the sun grows restless. Great eruptions called solar flares or coronal mass ejections send waves of plasma across space. When one of these waves strikes Earth, the magnetic field shudders, auroras expand toward the equator, satellites tremble in orbit, radio signals waver. On the ground, power grids can feel the surge of cosmic electricity. The sky becomes alive with energy. It is a reminder that our planet, though strong, lives within a larger storm, the weather of the sun. The upper atmosphere also hosts rarer, stranger phenomena, brief flashes of light that dance above thunderstorms, reaching toward space. Scientists call them sprites, elves, and blue jets. Sprites are towering red columns of light that flash high above storm clouds, sometimes as tall as 50 kilometers. Elves are circular glows that spread like ripples in water, expanding for only a millisecond. Blue jets shoot upward from the tops of storms like narrow spears of lightning. For centuries, they went unseen, hidden by the distance and the speed of their lives. Only with modern cameras did we realize how alive the sky truly is. In these high realms, air no longer behaves as it does below. Winds flow in waves that can circle the entire planet, gravity waves, ripples of air caused by mountains, storms, or ocean currents. They travel upward, carrying energy from the surface to the edge of space, where they help shape weather patterns thousands of kilometers away. These invisible tides connect all layers of the atmosphere, tying the smallest breeze to the grandest jet stream. And there are jet streams, mighty rivers of air that flow high above the ground, moving hundreds of kilometers per hour. They form where warm and cold air masses meet, creating corridors of speed that guide the movement of weather systems across the world. Airplanes ride these currents to save time. Storms follow their paths like leaves in a fast river. The jet streams are the skeleton of global weather, unseen but essential. Beyond them lies the thermosphere, where the air grows thin but the temperature soars, reaching thousands of degrees under the sun's ultraviolet radiation. Here, atoms move so far apart that heat has no meaning as we know it. The auroras shimmer in this region, and satellites drift silently through it. The International Space Station orbits within its lower edge, passing through a place where the last breath of air brushes the beginning of space. And farther still, in the exosphere, there is almost nothing, just atoms of hydrogen and helium escaping into the dark. Yet even here, the Earth continues to breathe. Every second, particles drift outward, carrying traces of our world into the void. They will travel for ages, perhaps reaching another star someday. This boundary, where sky becomes space, is not a hard line, but a blur, a slow fading. It is called the Kármán line, roughly 100 kilometers above sea level. Below it, planes can still fly. Above it, they cannot. It is the symbolic edge of our atmosphere, the limit of weather, the threshold of the infinite. At that altitude, the world below looks fragile, a thin blue halo wrapped around darkness. The entire atmosphere, all the storms, clouds, winds, and rains fit within that faint ribbon. Seen from above, it seems impossible that something so delicate could hold oceans, forests, and life. Yet it does. The sky is both fragile and strong, a miracle of balance, sustained by physics, sunlight, and time. Even beyond the edge, weather does not truly end. The solar wind, a stream of charged particles from the sun, flows endlessly through space, shaping magnetic fields, bending around planets, and carrying storms between stars. These cosmic winds are the weather of the universe itself. When we step back and see it all, from the calm of the troposphere to the shimmering crown of auroras, the atmosphere becomes more than air. It is a bridge, a living boundary between matter and light, Earth and cosmos. It is where energy transforms into color and silence turns into motion. Every storm, every cloud, every glow in the upper air is a part of this great system. Together, they create the breathing of the planet, invisible, endless, harmonious. In the next part, we will turn our eyes downward again to the surface of Earth, to the great cycles that bind land, sea, and air. We will explore how mountains shape weather, how forests make rain, how oceans feed the sky, and how everything, from the smallest leaf to the largest storm, belongs to one continuous story. Down on the surface of the Earth, weather is not only made in the sky, it is born from the ground, from the forests, from the oceans, from the quiet breathing of the planet itself. Every drop of rain, every gust of wind, every passing cloud carries the fingerprints of the land below. The Earth is not a stage for weather, it is a partner in the dance. Let us begin with the oceans, the vast blue lungs of the world. They cover more than 70% of Earth's surface, absorbing sunlight by day and releasing warmth by night. Their waters hold the planet's memory of heat, smoothing out the extremes of cold and warmth. The ocean is not still. It flows in great currents that circle the globe like arteries of heat and salt. Near the equator, the sun's rays strike directly, warming the surface and setting water to motion. Warm currents like the Gulf Stream flow toward the poles, carrying energy from the tropics. Cold currents flow back from the poles toward the equator, creating a slow exchange that keeps the planet's climate in balance. Without these currents, some regions would freeze while others would burn. The oceans also breathe into the sky. When sunlight warms the surface, water evaporates, rising into the air as invisible vapor. This vapor is the raw material of clouds, the substance from which weather is born. Over the course of a single day, more than 1 trillion tons of water leave the ocean and return again as rain. The same molecules may rise over one sea, fall over a forest, and flow back into another. In the tropics, this endless evaporation fuels some of the most powerful weather systems on Earth, monsoons. When the land heats faster than the sea, air rises over the continent, drawing in moist air from the ocean. The result is a seasonal reversal of winds that brings months of rain. The monsoon is not just a storm, it is a rhythm, the heartbeat of billions of lives. It fills rivers, nourishes crops, and cools the land after long, dry seasons. Without it, much of Asia and Africa would turn to desert. But water does not belong only to the sea. It also lives within the forests. A single large tree can release hundreds of liters of water into the air each day through transpiration, the slow breathing of leaves. In vast forests like the Amazon, this process creates a cycle of rain that sustains itself. Moisture rises from the canopy, forms clouds, falls again as rain, and begins anew. Scientists call this the biotic pump, a natural system where life helps create its own weather. When forests vanish, the air grows drier, the rains fade, and the land begins to thirst. The connection between trees and sky is invisible but profound. Every drop of sap, every rustling leaf, every shadow on the forest floor participates in the making of clouds. In this way, the forest is both earth and sky, both root and rain. Mountains, too, shape the weather in ways both dramatic and subtle. When moist air moves across the landscape and meets a mountain, it cannot go through it. It must rise. As it climbs, the air cools, and its water vapor condenses into clouds, forming rain or snow. This is the orographic effect, the reason one side of a mountain is often lush and green, while the other is dry and barren. The mountain drinks the clouds, and its shadow becomes a desert. In the Andes, the Himalayas, the Rockies, everywhere the earth rises sharply, weather transforms. Snow gathers at high altitudes, feeding rivers that flow down into plains. Those rivers carve valleys, shape ecosystems, and carry life far beyond the mountain's reach. The same process that forms a cloud on a peak gives birth to the stream that waters a forest hundreds of kilometers away. Even deserts, which seem empty, have their own weather. They are not places without life, but places where the sun rules absolutely. The air there heats quickly by day and cools rapidly at night, creating strong updrafts and shimmering mirages. Winds sweep across the sand, sculpting dunes that move like waves frozen in time. Dust lifted from these deserts travels across oceans, carrying minerals that fertilize distant rainforests. The Sahara feeds the Amazon. The Earth is one great circulatory system. Every environment, no matter how still it seems, participates in the global exchange of air and energy. The tundras reflect sunlight into space, cooling the planet. The jungles absorb carbon, softening the air. The oceans trap heat and release it slowly. Volcanoes send gases high into the sky where they can dim sunlight for years. Even the smallest living things, the plankton in the sea, the moss on the stones, play a role in the chemistry of weather. The cryosphere, the realm of ice, is another great architect of climate. The bright surfaces of glaciers and polar caps reflect sunlight, keeping the earth cool. When they melt, that balance shifts. Darker oceans absorb more heat, which melts more ice in a feedback loop of warming. Yet ice also gives life. It stores fresh water for billions of people, carved into mountains like a silent reservoir. In spring, its melt feeds rivers that flow to the sea, linking high peaks to coral reefs far below. The Earth's systems are not separate but intertwined. A storm in the Pacific can send ripples through the entire atmosphere, changing weather in North America or Asia weeks later. A volcanic eruption in the tropics can cool the entire planet for years. Even small things, the growth of plants, the migration of animals, influence the balance of gases in the air. The planet is a web of feedbacks, endlessly adjusting itself toward equilibrium. Within this web are subtle patterns, invisible highways of moisture known as atmospheric rivers. These long, narrow bands of air carry water vapor across continents like hidden streams in the sky. When they make landfall, they release torrential rains, filling rivers and sometimes flooding valleys, but they also nourish forests and recharge aquifers. A single atmospheric river can carry more water than all the rivers on Earth combined, not in liquid, but in vapor. Even the rhythm of the oceans changes with time. Every few years, the Pacific breathes in and out through cycles known as El Niño and La Niña. During El Niño, warm water gathers in the eastern Pacific, altering rainfall and wind patterns around the world. Some places flood, others dry. During La Niña, the opposite happens. The eastern Pacific cools and global weather shifts again. These oscillations are ancient and powerful, capable of shaping harvests, monsoons, and even human history. The complexity of all these systems is immense, yet they operate with quiet precision. The angle of the sun, the pull of the moon, the spin of the earth, all work together to guide wind and water, cloud and storm. It is a symphony without conductor, and yet every note is in tune. When we look at the world this way, the weather becomes more than a collection of events. It becomes a living process, a conversation between earth and sky. The rain that falls on a mountain may feed a river that nourishes a forest, whose trees release vapor that returns as clouds, and the cycle begins again. This circularity, this endless renewal, is what makes the planet so rare. On other worlds, weather may exist, but only Earth has a climate shaped by life itself. Our planet breathes, its oceans pulse, its forests exhale clouds, and through it all, the atmosphere listens, changing, learning, evolving. In the next and final part, we will look beyond the science into the philosophy and beauty of weather itself. We will explore what storms, winds, and skies teach us about impermanence, connection, and the balance between calm and chaos, the eternal language of the living earth. Weather is more than the air that moves above us. It is the pulse of the planet, the constant rhythm that connects land, sea, and sky. It shapes not only the surface of the earth, but the stories we tell, the lives we live, and the emotions we carry. For as long as there has been thought, humans have looked up at the changing sky and seen themselves reflected there. A calm morning mirrors peace, a storm mirrors turmoil. When the sky opens and rain falls softly on dry ground, something inside us loosens too. When thunder rolls across the horizon, we feel its echo in our bones. The weather is not separate from us. It is a reminder that everything alive moves in cycles, just like clouds and wind. From the smallest droplet to the greatest hurricane, every form of weather tells the same truth. Nothing stays still. The universe breathes through change. Every drop of water that falls today has lived many lives. It has risen from the sea, drifted in clouds, frozen in glaciers, flowed in rivers, and slept underground. It may once have been part of an ocean where ancient fish swam, or a storm that brushed the leaves of the first forests. It may have fallen on the stones that would one day become cities. In time, it will rise again, continue its journey, and begin anew. This cycle is endless. There is no beginning and no end, only transformation. What we call weather is the visible expression of that transformation, the face of the planet's endless renewal. When wind bends the grass in a field, it is energy made visible. When clouds gather on the horizon, it is the conversation between air and heat. When lightning splits the sky, it is the universe reminding us that even chaos follows its own rules. We often think of weather as something to endure, a storm to wait out, a flood to survive, a drought to overcome. But to the planet, these are not disasters. They are part of its balancing act, the exchange of energy and matter that keeps everything alive. Rain erases dust, fire renews the forest, winds carry seeds to new lands. Even destruction makes room for growth. Every calm day owes its peace to the storms that came before it. If we look closely, we can see how weather mirrors the rhythm of life itself. We, too, are shaped by invisible currents. Thoughts and emotions move through us like winds. Moments of clarity break like sunlight through cloud. We have our tempests, and we have our clear skies. The trick is not to resist either, but to see them as parts of the same system. Just as the earth learns to balance its forces, so can we. Consider the way a storm forms. Heat rises, cold descends, motion builds until it finds a way to release its tension. Once released, the air clears. The same is true for the human heart. Tension builds, emotion erupts, and peace follows. Nature teaches balance not through stillness, but through flow. In every culture, weather has been a symbol of the divine, the mysterious, the uncontrollable. The Greeks saw thunder as the voice of Zeus. The Norse called the wind the breath of Odin. In the East, rain was a blessing, a sign of renewal. Across the world, people learned to live with weather as one lives with time, not as a master to be conquered, but as a teacher to be heard. The sky is our oldest teacher. It tells us that nothing lasts, not storms, not seasons, not even sunlight. And yet, in that impermanence, there is meaning. The transience of clouds reminds us that beauty often lies in moments, not permanence. The passing storm leaves behind air that is cleaner, clearer, more alive. Weather is the art of impermanence written on a planetary scale, a fog rolling over a quiet lake, a bolt of lightning across a summer night, the golden hush of air before rain, the deep blue stillness after snow. Each of these moments lasts only briefly, yet they are enough to make us stop and feel the world breathing. In the end, weather connects everything. The air that touches your skin tonight may have once passed over the Himalayas, across deserts, above forests and oceans. The same molecules of oxygen may have been breathed by ancient creatures millions of years ago. The same hydrogen in the water that falls as rain was born in the core of stars long before the Earth existed. Weather is not merely Earth's system, it is the universe continuing its work through us. The sunlight that warms the ocean today began its journey in the heart of the sun 10,000 years ago. The wind that stirs the trees carries energy from stars that burned before our own was born. We live inside the circulation of creation itself. When we stand beneath the sky, we are not beneath it at all. We are within it. We breathe it. We shape it. We are made of the same elements that flow through it. The nitrogen in our blood, the oxygen in our breath, the water in our cells, all come from the air. When we exhale, we return them. The atmosphere is not a border between us and the cosmos, but a shared space. Every breath is a tiny exchange with the planet. And so, when we listen to the wind, we are hearing the planet speak in its oldest language, the language of motion, temperature, and light. Science can measure the patterns, but wonder gives them meaning, because weather, like music, cannot be owned. It must be experienced. It passes through us, leaving feeling instead of form. Perhaps that is why storms draw our eyes to the sky and sunsets still silence us, no matter how many we have seen. Deep down, we recognize something of ourselves in them, fleeting, luminous, and endlessly changing. In the grand scale of time, we are as brief as a spark of lightning, a single drop in the planet's rain. But that does not make us small. It makes us part of something vast. The same processes that move clouds move us. The same balance that holds the atmosphere together holds our lives together. We are weather, living, changing, balancing, transforming. And when the wind dies down and the clouds drift apart, what remains is always light. That is the final truth of all weather and of all life. No matter how long the storm lasts, the sky remembers how to clear. No matter how heavy the rain falls, the air will one day be calm again. The earth never stops breathing, and neither do we. Everything, the wind, the water, the clouds, the thunder, the quiet, belongs to one endless rhythm, and within that rhythm lies peace.